Welcome to xPilot, an AI software engineering agent with a mission to accelerate development on Multiverse X. xPilot is a VS Code extension that can be installed in any VS Code compatible IDE. We are about to see how we can perform different tasks such as creating accounts, fund them, make transfers, create smart contracts, build, deploy, modify, and upgrade them, call endpoints, and view functions on the blockchain, all in natural language without writing a single command or code. This is possible by using an innovative method that we developed with xPilot to use the Model Context Protocol to allow large language models to know how to perform tasks they were not trained for. So, let's start by creating a new account wallet. xPilot takes the request and instructs the model how to understand what we're asking. Now, we can see how the model wants to access a specific resource called Creating Wallets that it determined it would help complete the request. By reading the response to that resource, the model obtains specific information about completing the request, in this case, using the MXPY CLI tool with required parameters. Since it didn't receive all necessary parameters from us, the model is asking about a name for the wallet file. Let's call it Alice. With all information it needs now available, the model is constructing a terminal command to create the new wallet file. Let's give xPilot permission to execute the command. For key store wallets, we need to provide a password for encrypting the private key. We can now see the new wallet file is created. Let's now create a new account wallet file named Bob. This time the model already knows the wallet file creating information, as it is already stored in the current task context window memory, and generates the new command for us to approve. We specify a password in the terminal for Bob, and the new wallet file is also created. After completing the request, we also receive helpful information about handling wallet files. Now, let's add some test funds in the Alice's account on the Multiverse X DevNet network by asking xPilot. Since it doesn't yet know how to do that, the model reads an available resource named Funding Accounts that allows it to get more information. The resource content instructs it how to construct a new terminal command. Let's run that command and provide the password for the wallet file in the terminal. The command execution opens a web browser to the DevNet wallet faucet that allows for requesting tokens. Let's wait for the transaction confirmation and then close the browser window. Let's now check the balance of Alice's account from xPilot. Having a new request to perform, the model will look for available resources that can help. It finds and reads a resource called Getting Accounts Info. As before, it uses that information to construct a terminal command to get the account balance. We can see there are now 5 EGLD tokens in Alice's account, the denominated value that natively has 18 decimals. Let's ask xPilot to transfer 1 EGLD to Bob's account. Another available resource named Executing Transactions is read, and a new command is constructed. Let's run that command. We need to specify the wallet password again and wait for the transaction to complete. Now that the transaction is completed, we can see a transaction summary, along with a link on DevNet Explorer for that transaction. Let's check it out. We can see 1 EGLD was transferred to Bob's account that now has a balance of 1 EGLD. Checking Alice's account, there is a balance of 3.9999 EGLD, accounting for the transaction fee as well. Now, let's get into a more exciting endeavor, creating a new smart contract. We're going to use a simple template from the available templates. A new resource is accessed, named Creating Contracts. The model now asks for a contract name and which template to use for creating the new contract. We'll name the new contract Demo Contract, and we'll use the simple adder template. The model now determines the command to create our new contract using SC Meta CLI tool. Let's run it. We can see a new folder was created with the demo contract. Since the resource about creating contracts also contained information about actions such as build, deploy, and upgrade, the model now asks us if we want to build our new contract. It's time to build. It's always time to build. While we're waiting for the libraries to compile for the first time, we would like to say that we are very excited about the potential of xPilot. As we can see, we can instruct a large language model to understand and perform any action describable in natural language. The architecture is extensible and anyone building on Multiverse X will be able to provide their own integration. Now that the contract has been built, we can see a summary displayed. Can you believe it has only 696 bytes? That's the power of WASM. Let's deploy it on the blockchain. We'll use Alice's account on DevNet. The model now reads a resource named Deploying Contracts and constructs a deploy command. It suggests the contract doesn't need any initialization arguments, but let's check the contract implementation. The adder template we used is for a simple contract that stores a value on the blockchain named sum that has an initial value in the init method, which is the contract's constructor method. We have to specify the init method arguments when deploying or upgrading the contract. Now the model uses that information to add the necessary arguments to the deploy command. Let's run it. The deploy transaction has finished. We can now see a summary of the transaction, including the details on the DevNet Explorer. Let's check it out. The deployment was successful. We can also check the transaction history on Alice's account address. We can see the last SC deploy transaction for the contract. Now let's use a query to check the initial value of the sum stored in the contract in the sum storage mapper that also has a getSumView function. The model reads yet another resource named Querying Contract Views to determine the appropriate command for the query. Let's run it. We can see the value of 10, which is what we specified when we deployed the contract. Now let's call the add endpoint function to add a value to the sum stored in the contract. Let's add a value of 40. The model has read a new resource named Calling Contract Endpoints. It will construct a command to call the add endpoint function. Let's run it. The add call transaction has finished. The model suggests querying the getSumView function again to check the new value. We can see the new value in the contract is 50, which is what we expected. We can also see a summary of the transaction and a link on DevNet Explorer. We can see the call to the add endpoint function, the first transaction in our contract. Now, let's modify our contract and add an endpoint to subtract from the value. Let's ask xPilot that. The model now reads the contract's code file to implement our request. The model automatically edits the file and adds the new function. Our new endpoint function has been implemented. The model suggests building the contract, which is what we want. It then proceeds to read a new resource called Upgrading Contracts to determine the command to upgrade our contract. It determines calling the upgrade with an argument of 50 to preserve the current contract value. Let's do it. The upgrade transaction has finished. Now it suggests calling the getSumView to confirm the previous sum value was preserved. Sure enough, the sum value is still 50. We can see a summary of the upgrade and a link to check the transaction on DevNet Explorer. We can also see all the transactions made by Alice's account, the last one being the contract upgrade. Now, let's call our newly added subtract endpoint function to subtract a value, let's say 20, from the sum stored in the contract. The model determines our function call command. Let's run it. The subtract transaction call is finished. We are presented again with a suggestion to call the getSumView to check the new value stored in the contract. Sure enough, we can see the new value is 30. As before, we can also check the details on the DevNet Explorer. We can see the upgrade contract and the subtract transactions in the contract's transactions list. Okay, so we've seen how xPilot works with an AI model and instructed how to accomplish different tasks. We've seen the model accessing different resources that contain information about how to think about solutions to requests. Here, for example, how to call contract endpoints or querying contract views. But where is this information coming from? Well, the information is coming from connected model context protocol servers in xPilot. For example, there is a MCP server having information about how to use the MultiversX Python SDK CLI tool called mxpy. In the resources section, there are several resources describing how to use mxpy commands for different purposes that we have seen being used throughout this demo. There is also a MultiversX Rust SDK MCP server that provides information about how to use the scmeta CLI tool to create and build smart contracts. We can add any number of MCP servers that can be activated or deactivated for the current context. While we have so far seen only servers offering static resources, MCP servers can also expose dynamic API calls. Here is an example of a server calling the MultiversX API service. Let's call it to find out the current EGLD token price. Everything we did until now was in a single xPilot task that builds a context window memory with all the information stored and available to the model at each request. but it can be impractical to build a very large context memory. So if we want, we can save all the relevant context memory to a file for future reference at another time, with less context token usage when we start a new task. The model can go through all the information accumulated in the current context window and save only data it determines is necessary, such as wallet files, accounts and contracts addresses, networks used, transactions performed, and so on. It then can use this information when starting a new task to get up to speed with all the previous history. Here, it generated a task summary markdown file with everything that we did, and we will use this file to start a new task from scratch. Let's use the Start New Task button and close all the open files to start a fresh task with no previous context memory. Now let's first instruct a model to read a previously generated task summary file, and then do a query by only specifying the name of the view function. The model reads the summary file and then determines what other information it needs to complete the request. Then we can see it reads the contract file to understand the contract implementation. Then it reads the resource about querying contract views. Then, having all the necessary information, it determines the command to query the view function on the previously deployed contract. If we run the command, we can see the query working as in the previous task that had the full context. We can switch at any time between any previous tasks from task history to resume work on that task context. There is much more to discover, but this is all for the purpose of this demo. We hope we got you just as excited as we are. If you are interested in xPilot, you can follow our X account at xPilot AI. Thank you for watching, and remember, it is always time to build.